Hello and welcome back to the GeoPython Advanced Workshop Part 2. In this part we're going to be diving into loops, automatic material optimization and plot generation. First of all, I would like you to go back to Geodict, go to Macro, execute macro script, and unfold the project folder if necessary. Select workshop3.py, the last file we worked on, and click Edit down here. Then the editor should come up again. And now please first save the file as, so go to File, Save As, workshop4.py. Now we go all the way down. Probably your this function is unfolded now for you. Let's just fold it again. So click the minus in front of the def again. And let's remember what we did last time. We wrote this function which generates a fiber structure with the given solid volume percentage, runs a flow simulation, grabs the permeability value from that result and returns it. And then we added a line which calls this function with a fixed value of 25, so SVP 25%, and shows the resulting permeability value. What we want to do now is loop over a certain range of values for SVP and call the function for each SVP value and display the corresponding result. To do this, we introduce a for loop. Please go to the line just above the perm assignment here and write for SVP in range 5, 50, 5. Closing bracket, colon. Now what this does is it varies the SVP value in a range from 5 to 50 with a step of 5. And so it starts at the value of 5, increments that by 5, so it's 5, 10, 15, up to but not including 50. So that's what this for loop does. And we take the rest of the code and we indent it once again so that this is actually executed in the body of the for loop. So we have this SVP value, which varies from 5 to 45 inclusive. And then we replace this 25 here by this variable SVP. So for each iteration of this for loop with a different SVP value, our function is called, the corresponding permeability is obtained, and that permeability is then displayed on the screen. Now to make this a bit nicer and to actually know to which SVP this permeability that we're seeing corresponds to, we replace this perm in the brackets and we write instead F, the permeability for a SVP of curly brackets SVP is curly brackets perm. Full stop. So we've seen this construct before. This is for format string because it's introduced by an F, which means nothing but that Python will go and replace these parts of the string which have curly brackets by the corresponding variable values. So we will get sentences like the permeability for an SVP of 5 is some number. And this is what's going to be displayed. So we know after each run, we know the corresponding pair of solid volume percentage and permeability. Now let's save the file by pressing Ctrl S and let's go back to Geodict to try it out. If necessary, open the macro execution dialog again by going to macro, execute macro script, unfold the project folder, possibly hit refresh until you see workshop4.py, select it, and click run. If anytime when you're prompted to overwrite, just click overwrite. And now we see the first result. So it says the permeability for SVP of 5 is 8.8 E minus 11. Now if you press OK, it'll do the next run. And we get the next result, permeability for SVP of 10, etc. Should probably run more smoothly for you because I had some intermediate results here, which asked me to override a few more times. But you will get a message box for each intermediate result. So now we basically have created a very simple parameter study. And as many of you might know, we could have also done this by using very macro functionality. By introducing this SVP as a variable of the macro, we could use the vary functionality, which is hidden behind that button, and we could have just entered a range of numbers for which to run the macro, and it would do the same thing basically. But what the vary functionality cannot do is, for example, aggregate these results. And one form of aggregation is to plot the results. And this is what we're going to do now. So please go back to the editor. So possibly go to Workshop 4 and edit, or just go back to Notepad++ if it's still open. And again, save the file now as workshop5.py. By the way, up here you can see all the results that we've created in the last run. So FiberGeo results and Stokes results, etc. So save it as workshop5.py. And now we're going to go and plot the actual plot the permeabilities against the solid volume percentages. So for this, please, for now, just delete this part, delete the for loop. And then we're going to do import matplotlib.pyplot as plt. Matplotlib is the most famous Python plotting library and probably the most famous plotting library overall. And you can find many tutorials and lots of documentation about it online if you want to change the plot, for example. And we'll start by doing SVP values equals list of range 555. So now we go and take this range of SVP values, so that's 5, 10, 15, etc., up to 45 again, turn it into a list and store it in a variable. We do this because we need this in two places, as you will see. So I'll just write it once. I don't want to repeat this. And we also define a list of permeability values, but this list is initially empty. So equals empty brackets. So this is a list of values of 5 to up to 45 in steps of 5, and this is an initially empty list. But we're going to compute the permeability for each SVP value, and then we're going to append it to this perm value. So after that, we're going to have a list of SVP values, and we're going to have a list of permeability values which correspond to each other. So again, we do a for loop for SVP in SVP values, colon. So actually this for loop now executes for the same values that we had earlier, because this is just a list of the same SVP values as before. So now again, this is actually the same line as before. So perm equals create structure and run simulation of SVP. So run the simulation for that SVP and obtain the permeability. And then we do perm underscore values dot append perm. So this loop will again execute for each SVP value, obtain the permeability, take it and append it to this list of perm values, which is empty at the beginning, but at the end will be filled. Now we go back in the indentation to the front. So we start on the left-hand side again. So this signifies that we're outside the for loop again, and we do plt.clf. This clears the plot area if there's any plot in memory, basically. Then we add a plot, so we do plt plot SVP values, comma, perm values. What this does, it plots x and y values. So we have SVP values on the x-axis and y values on the perm values, and it connects them with lines. And then, unfortunately, we cannot just automatically show the plot on screen. So what we're going to do is we save the plot as a PNG file. So we do plt save fig, which stands for save figure, and we say permeabilities.png, which saves the plot that we have generated here as an image as permeabilities.png. So save the file, and let's try it out. So we go back to Geodeck, macro execution, and possibly hit refresh till we see workshop5.py, select it and click run. Now it'll ask again to override several times, so just click override. And now we should go into the project folder with the Explorer. So go to the workshop folder, go to project folder, and there we should see a PNG file called permeabilities. Just double click it to open it. And we can see a simple plot which plots the SVP. As again, this goes from 5 to 45 versus the corresponding permeabilities with this scaling factor here. And of course, you can make this plot nicer, but this would be kind of outside the scope of this tutorial. But you can find, as I said, many matplotlib examples online. So, for example, to manually set the scale of the axis, give a title, or give an axis title for the x and y axis. Now let's assume you have a good geodetic model of a material with a free parameter. For example, you have a fiber geostructure generation as we have here with a solid volume percentage as a variable. And now you want to, your goal is to find a material within that parameter space which has a desired target permeability. For this purpose, we can do a simple automatic optimization loop, and I will show you how. Again, open the workshop5.py and save it as file save as workshop6.py. And now we'll go and remove all this plotting code, so all the stuff below the function. And we will begin as follows. Say you have a given target permeability. Here we will give a fixed permeability, but of course you could make this a macro variable, for example, so that the user can give a target permeability from outside. So let's say 10e minus 12. And then we have a certain range of candidate SVPs that we want to search. Let's say SVP min equals 5 and SVP max equals 50. So we want to have an algorithm which basically searches the range of SVPs between 5 and 50 and tries to hit a target permeability of 10e minus 12. And we will do a for loop over 10 steps. So we will do 10 optimization steps. And hopefully after those 10 steps, we will be close to our goal permeability. So we write for I in range 10. In this case, we're not going to be using the variable I within the loop body at all. We just want the whole thing that comes inside the loop to run 10 times, basically. So the first thing we do is we calculate an SVP based on SVP min plus SVP max in round brackets divided by 2. So this basically picks the midpoint between SVP min and, this should be max. This picks the midpoint between SVP min and SVP max as a first starting point. Then we compute the permeability again for that SVP. So perm equals create structure and run simulation of SVP. So now we get a permeability for this SVP value. Now we can check if this permeability value is larger or smaller than our target permeability. So if perm is larger than target perm, then our permeability for this SVP value here is too large. So what we want to do is we set SVP min to SVP. So we basically change the search range from SVP min to SVP max to SVP to SVP max. So we basically pick one half of our search space, the upper half in this case. And if the permeability is, in the else case, if the permeability is lower, we say SVP max equals SVP. So in this way, we pick the lower half of the search space. And the condition that the permeability would be exactly equal to the target permeability is not going to happen. So that's something you don't need to think about at this point. So what this does is it's a simple bisection algorithm. Of course, this is an oversimplification because it assumes that the correlation between the SVP and permeability is strictly monotonous, and it also ignores the random, the stochastic nature of the structure generation in this case. But it's a simple approach that can sometimes work and is definitely a good introduction for what you can do. So this loop will then run for 10 times, and it will in each step it will pick one half of the current search space. So it'll start with 5 to 50, and then it will pick the upper half or the lower half, and it will continue for 10 times. And then we output the final SVP value again with a format string. So this is the SVP value that it has at the after the last iteration of the loop. And we can insert a new line here by writing \n and then permeability colon perm. So this will output two lines in a box again with the final SVP value and the final permeability after this 10-step optimization process. So let's save this file. Oh, and I'm sorry, it should of course be message box, not message. So MSG box, save again. And now we can go to Geodict and try it out. So again, if necessary, hit refresh in the macro execution dialog till you see workshop6.py. Then click run. And now if it should ask you to override, just click override, please. So now it runs this 10-step optimization loop, and it is guided by the relation between the permeability and the target permeability. Depending if it's higher or lower in each step, it changes the direction of the search basically. So basically it narrows it down with bracketing. So now we get an output. We have a final SVP. We have a final SVP of 19.5 and a corresponding permeability of 9.9 E minus 12, which is relatively close to what our target permeability was. And we can see what it did when we go to Explorer, go to our project folder, and we can see that it tried all kinds of permeabilities here. And we can see it in the FiberGeo names that it has narrowed down towards the 19.5 range. And again, as I mentioned, this is a very simplistic approach, but in cases where you have really a monotonous behavior between the input and the output variable, this can save you a lot of time in getting a structure close with properties close to your target properties. Because otherwise you would probably be doing a grid search. So as we did earlier, just test different SVPs in regular intervals, and then after the fact, after all your simulations are finished, you pick the one which is closest to your where the permeability is closest to your target permeability. But this is a much more intelligent approach if there's such a monotonous behavior, and it gets you close. It gets you much closer to the target value with less steps, possibly. So this concludes the second part of the GeoPython advanced workshop. And in the third part, we're going to be talking about how you can create custom PowerPoint reports from your simulation results. Now, there's again a 15-minute break where you can ask questions if you want in the chat or even orally. And we're going to be seeing each other then after this break.